Hello, everybody, and welcome to the Theano office hours. Thank you for joining. As before, this is a Q&A session for the Theano class we had last week. It's our goal to help answer any questions you have related to Theano, as well as the hands-on lab you likely have taken in the last week. As before, we'll do all our questions and answers via the chat window, and then while that's happening, our presenter, John Barker, will also verbally answer some of the more high-value questions we've gotten in the last week or he thinks everyone should hear about. As a side note, the lab apparently broke this morning. There was a license issue. So if you haven't taken the lab yet, I've deactivated it for now. I should hopefully have it fixed shortly after this office hours is over. Then I'll reactivate it. But if you tried to take it this morning, I know a few people had. That's the problem you likely saw. As with all our previous classes and office hours, all the recording and the Q&A log and any slides we use will be posted on our Deep Learning course website. We have one more class coming up, so you can go there to see the schedule and get all the past information. So let's go ahead and start sending us in your questions, and I'll turn it over to John.
Okay, good morning. Thanks for participating in the Q&A today. I'm going to start by revisiting a couple of questions from last week that I wasn't able to answer fully, and then go through a few more prepared questions, and then once your questions start coming in over chat, I'll answer as many of them as I can. So the first question I wanted to revisit from last week was, how does one use Theano with multiple GPUs? So the way that this is done is by using the Python multiprocessing module. If you're familiar with that, it's a module that allows you to create child processes from a central master application, and each of those child processes can then be assigned to a different CPU thread. Or in this case, what you do is that you would have a main parent application that's been launched with Theano using the CPU. That's an important step. And then you launch multiple child processes, one for each GPU. And then within that process, you actually override the device that Theano is configured to use to assign it to the particular GPU. So that's a general model for launching Theano scripts on multiple GPUs. It doesn't actually tell you how you would actually distribute a deep neural network training workload so that you would see good performance scaling. And that's a much more complicated subject, which is really beyond the scope of this course. But as I mentioned last week, if you want to read into that topic of how do you actually parallelize the training, then you want to look up the terms data parallelism and model parallelism for deep learning. I'm going to paste a link into the chat, which is produced by the Theano developers and explains how you'll do multi-GPU training using that multiprocessing module. Okay. So second question was the question was asked was, how can I inspect values that are updated? And I think what was being asked there was, how do you monitor the progress of training using Theano as your different parameters of your network get updated through your stochastic gradient descent? And a related question is how would you visualize the filters that are learned in a convolutional network? So there's two ways that this is commonly done in Theano. So if you remember that the Theano workflow is that you first define your symbolic variables, then your symbolic expressions, and then finally a Theano function which compiles those for computation. One of the things, the parameters you can define in that Theano function is what will the output of the function be, so that each time the function is run, it will return that output, and that can be one of the one or more of the parameters of your model. So a way that that's commonly used is that you define the cost, the training cost, to be an output, and you can then visualize that cost if you want, so that you could see a graphical representation like you would get in digits of how your training and validation costs are progressing. You can also use that to output, as I said, any parameter of the network, but it's not typically used to return large variables. So for example, you don't typically use that method to return your weight matrices each time you run the function, because that's going to slow your training process down significantly. Because, for example, if that data is residing on your GPU, you're asking it to be copied into main memory each time you do that. So the second method for retrieving the state of symbolic and shared variables is the get_value method that's associated with the variable. That can be used to retrieve the current state of any variable in the Theano computational graph. So that is the sequence of symbolic expressions that you're using. Again, that introduces an overhead. So you may want to not retrieve the status of your filters after every iteration, but maybe set it to do it every 10 iterations for visualization, for example. Or even you may use the method just once the model has been trained. There is also an accompanying set value function, set_value method for variables if you want to manually modify their value during training. Okay. So how does Theano work with large-scale data? There's been a few questions today, last week, that were unanswered about that really the answer is quite application dependent. So I'll try and answer them as best I can in general. But in this case, really the question is, well, how does Python handle large-scale data? Theano functions, as we discussed, really just take as input tensor representations of data, so multi-dimensional arrays of data. So essentially, you need to get your large data into that form. So that leaves many options for how you would transform raw data into input tensors. For example, if you're working with images, you might use something like the Python imaging library or OpenCV to extract the pixel values and flatten that image into a vector and then form a batch of images that way and pass that into Theano. But the precise choice of how you do, what packages you would use to do your data processing and data management is really application and data dependent, but the key point is you're not limited at all within the Python ecosystem. So any package that can help you there from Python is going to be compatible with Theano. Often for saving and retrieving model parameters, people use Python pickle objects. As we discussed earlier in this course, the actual byte size of your model parameters is not huge, and so Python pickle objects are usually sufficient for storing and retrieving model status. I guess one deep learning specific aspect of handling large-scale data that we've seen when we used Caffe is that you have to you do what's typically called mini-batch gradient descent. So you pass in a batch of images at a time to train, because that allows you to exploit parallelism in feeding those images into your neural network. Well, Theano definitely supports that. You'll have seen an example of that in the lab, I think, but certainly you have complete flexibility to pass batches of data into a Theano function. Okay. Another question that was related actually to handling large-scale data, I assume because people were familiar with these technologies from the Caffe webinar and lab was, does Theano support level DB and LMDB? If you didn't take the CAFE lab, level DB and LMDB are two fairly lightweight databases that CAFE uses for storing and retrieving data for neural network training. There are Python libraries available for reading and writing into level DB and LMDB databases. Much like I said with the data pre-processing and other data management tools, these are independent of Theano, but certainly can be used as a both certainly could be used as a database for raw data, which you would then extract a sample from and pass it into Theano as a input tensor. Okay. One question that came in over the chat was, does Theano run with any GPU? Actually, I think we had that one last week as well. Yes and no, mainly no. No, the main branch of Theano requires a CUDA-capable NVIDIA GPU. So you need to have CUDA installed so that CUDA can access your GPU. We internally have tested with Tesla K80s, K40s, K520s via Amazon Web Services and Titan X, as well as a number of GeForce cards. In the developmental branch of Theano, there is an OpenCL backend, but it's really still in its infancy. If you want to read more about how GPUs can be used within Theano, there's great documentation, and I will post a link into the chat. Oh, I think someone beat me to it. Yep. Okay. Would I recommend Theano over CAFE for a beginner? And it said specifically a beginner to deep learning. So I would recommend digits to a beginner for deep learning, which you saw in in the previous webinar and labs, because of it's got the web-based UI, very easy to use, no coding required, and has the multi-GPU support. After that, I think it really depends on what path you're going to take in the deep learning world. If you want to do deep learning research, but especially if it's mathematically oriented, so perhaps inventing new training algorithms or activation functions or layer types, then you might appreciate the very explicit representation of the models and algorithms that you get through Theano, but with its relatively simple scripting language that you get with Python. If you want to, but on the other hand, if you want to leverage tried and tested convolutional neural networks, but for novel applications to your own data, and you don't envisage heavily modifying the available layer types, for example, then you may want to dive into CAFE. I would also say, though, the choice depends on your programming language of choice, or if you have any restrictions on the programming language you can use in your development environment, and your performance requirements, and as I say, research interests. So I'd be happy to try and field any questions that are related to slightly more specific applications, but in general, I think either framework is a good place for a beginner to start. I guess in a few words, someone asked in a few words, what would I use Theano versus CAFE for? So I am a user of both fairly heavily. Personally, I use CAFE for convolutional neural network-based applications with images. Increasingly, I do that via digits, but not always. And I use Theano often as a learning tool, actually, when I'm trying to understand how deep learning operations are actually implemented efficiently, how they actually work in detail. And I also use Theano for unsupervised learning applications. It's not to say that you can't do unsupervised learning applications in other frameworks. but I found it clear how they are structured in Theano, and I've become used to that environment. However, both frameworks are very adaptable and they're rapidly evolving, so it's really important to keep track of their progress, see the commits that are being made to GitHub, etc., to ensure that you continue to use the right tool for the job when you start a new application. Okay. So a very important question that came up a number of times last week was, I talked a lot about the benefits in Theano of automatic differentiation. So the fact that when you've defined your symbolic expressions, which allow you to feed data into your neural network, you, in order to train the network, you use this method, stochastic gradient descent with backpropagation, and that backpropagation relies on the ability to compute the derivative of your loss function with respect to all of the network parameters. So, and in practice, working out those derivatives by hand can be complicated and is often unnecessary, as they're well known. So I stated that Theano can really help because it's very powerful because it can automatically differentiate those symbolic expressions. So the question was, that came in frequently was, is that done using finite differences or numerical methods internally? And the answer is no. And this is part of the power of Theano. It's done analytically, so it assumes that you have a differentiable function. Your loss function is differentiable with respect to your parameters. Now, what I would say about that is that that's almost always going to be the case if you are using the operators that Theano provides you, the tensor operators that Theano provides you, and any of the current well-known deep learning methods, then you're going to have a differentiable function. And in that case, all of those operators that you use within Theano have their analytical derivatives derived. So that means that Theano can make use of the chain rule from calculus and to chain together the different symbolic expressions and the derivatives of the atomic functions to get an expression, an analytical expression for the gradients, and then it has to simplify that expression, as just applying the chain rule naively will give you quite a complex expression. So it's quite a complex topic to go into the details of that, but yeah, the important takeaway is no, it's a symbolic differentiation, and it's almost always going to be available to you for deep learning. You can find out more information about Theano's use of symbolic differentiation at the link that I'm about to post into the chat. And we'll also, all of these links that I'm posting will also be retained in the PDF of the Q&A that'll go online. Finally, I wanted to just come back to the question about, someone specifically said, is the differentiation implemented using finite differences? Don't worry if you're not familiar with finite differences, but that's a numerical method that you would use for working out derivatives. Finite differences is actually used in Theano though, but it's not used for the symbolic differentiation for the gradient function. It's used optionally to check that the analytic gradients that are being produced are correct. So that's an optional testing that you can do in Theano. Okay. So do you know Python libraries that use CUDA to pre-process inputs, images or sounds, besides Theano? Well, so firstly, I mean, Theano doesn't directly pre-process images or sounds, although it certainly could be used to do so in some cases. but there's certainly no well-defined sub-modules within Theano for those tasks. Two popular libraries, Python libraries that use CUDA for tasks like that, or that could use CUDA, are PyCUDA and Anaconda Accelerate. PyCUDA allows you to access the actual CUDA API from within Python. So basically, it maps all of CUDA to Python. That means it's very expressive and adaptable, but it does require an understanding of how to efficiently implement your algorithm, your program in CUDA. It's also freely available, which is good. Anaconda Accelerate it offers GPU acceleration for a number of vectorized NumPy functions, as well as a variety of different application-specific accelerated functions. So for example, sorry, not application-specific, but linear algebra functions, Fourier transforms, for example. And Anaconda Accelerate is free for academic use, but it does have a commercial license cost. And so I'm about to put a link to our NVIDIA developer zone where you could find details of both of those tools. Okay. How do you know QDNn is being used for sure by Theano? That's a good question. There's a pretty easy way to check that. There's a optional flag in Theano. I mentioned last week about how you configure Theano using a number of different configuration flags, using either your .theano.rc file, or you pass them into Python when you run your script that uses Theano. So there's a flag that is called optimizer_including equals QDNn. If Theano is not able to use QDNn and you have operations in your Theano program that are supported by QDNn, then Theano will actually throw an error if you have that flag set. So if you believe you have operations that support QDNn, so for example, convolutions, pooling layers, softmax activations, then if you add that optimizer_including equals QDNn flag, then you would cause Theano to throw an error if QDNn is not available. Okay. So I'm trying to go through questions from the chat here. What is the rule to insert input and output shapes, and how do they vary in layer types? Okay, so I'm not 100% sure what is being asked there, but what I would say is when you use many of the Theano operators, so for example, if you are defining a convolutional layer and you use the theano.tensor.neuralnet.nnet.conv2d function, then that function will require as input parameters the shapes of the input images or the tensor of input images, so typically a 4-dimensional tensor, and similarly the shapes of each of the convolutional filters. And then the output shape you do not specify, but when you run that function, if you want to take the output from that convolutional function and pass it into another layer, you can simply query the shape of that output between those before you pass it into the next layer. If you want to clarify exactly what was meant by how do they vary in layer types, I'd be happy to try and answer, but it's not entirely clear. I mean, in general, it's a very broad question, as there are many different layer types with their own specific needs. Quick question, does Theano work with GPUs on Windows? Yep, you can use Theano on Windows and use GPUs, and I believe Julie is about to paste a link into the chat which will show you where you can, or Alison is about to paste a link that will show you where you can find installation instructions. Would I use Theano for coming up with prototypes, but in production implement them in Caffe? No, that not necessarily. That's kind of not an obvious progression. You could do that, but it's not an obvious progression. So it really depends again on your use case. But for many use cases, Theano would be suitable for production too. Conversely, if you're using a convolutional neural network for image classification, then you may want to just prototype in Caffe as well. I wouldn't necessarily say there would be a benefit from prototyping in Theano and then translating to Caffe if you're using a well-understood network type and application. So again, that all depends on the specifics of the application. I've mentioned a couple of times today and last week the use of the .theano RC file for configuration of Theano, and a question came in that someone couldn't find that file on their installation of Theano and Ubuntu. So it's not created by default. You can optionally create it yourself just using a text editor. You put it in your home directory, and then it's .theano RC as mentioned, and you can find the format. I will post the link for the format into the chat. We also had a question last week about the scan function in Theano. So the scan function is a way in which you can define algorithmic loops, but using symbolic expressions in Theano. So the developers actually recommend that you minimize your use of the scan function. It does introduce a computational overhead, but they have applications of where you might use it. So for example, if you're doing Monte Carlo simulations and doing something like Gibbs sampling, or if you're doing recurrent neural networks, then both of those can be implemented using the scan function, but it's not necessarily the only solution. I would recommend you dig into the documentation if you're interested, but yeah, the short answer is scan is a way to implement loops symbolically in Theano. Okay. A GPU-specific question here. What is the advantage of using a Tesla card? As I know, gaming card computation ability is higher than Tesla series card. It seems that Tesla cards are good at doing more precision calculations. But in deep learning, high precision seems not to matter so much. So GeForce cards can be used in a desktop system for developing and testing deep learning. Tesla cards are designed for use in a data center for when you want to do more extensive deployment. So the difference really is about the validation of the card, the amount of time you expect to be using it, rather than the computational ability specifically. Okay. Can I recommend on Lasagna, Keras, Pylon 2 blocks that are all based on Theano? Again, they're all great libraries. I've played with each of those. It is application specific. Well, less application specific, but they're all very similar. A few nuanced details. One comment I would make is that they vary in the level of abstraction away from Theano that you get. So, for example, Keras is probably the simplest of those in syntax. It's designed to look very much like the neural network package in Torch 7, which you'll hear about next week. But that does mean that much of the actual detail of the Theano implementation is hidden and somewhat harder to access than if you used Lasagna. But I don't really have enough data to recommend one of those over the other unless we went into the detail of specific applications. Okay. So would I use Theano for coming? Oh, we covered that one. Sorry. Does Theano support other machine learning algorithms like SVMs, random forests? So certainly SVMs. So in terms of support for those algorithms, it's much the same as answers I've given in other questions, which is there isn't a specific submodule, which is Theano.svm or Theano.randomforests. But Theano is a very general symbolic maths library, so potentially there are whole broad classes of machine learning algorithms that you could implement using Theano. In the case of SVM, there's actually a Theano tutorial which gives an example of an SVM. But for random forests, I haven't seen a specific example of doing that. But as I say, really, the beauty of Theano is that you can build almost anything you can imagine that you can write down in symbolic maths, but it doesn't necessarily package up all those different algorithm types for you. So this is a question from last week. There are better optimization methods than gradient descent or stochastic gradient descent. What is really supported in Theano? So certainly true, raw stochastic gradient descent is rarely used in practice because there are relatively simple extensions which can help it to run faster and help your optimization to progress faster and more stably. So there are advanced optimization methods such as Nesterov accelerated gradient and RMS prop. Both of those as examples can certainly be implemented in Theano. If you look at the source code of some of the libraries built on top of Theano, like PyLearn2 and Lasagna, you can see well-written, efficient implementations of those methods. But again, out of the box, Theano doesn't offer any of those methods. In fact, it doesn't actually offer you gradient descent or stochastic gradient descent. You will have seen in the hands-on lab that we had to define our gradient as a function. We called the gradient function to work out our gradients from our cost function, but we then had to define the update rules ourselves. When we defined those update rules, we were essentially defining the stochastic gradient descent algorithm. But stochastic gradient descent itself is not a built-in Theano routine. Instead, Theano gives you a versatile toolbox from which you can build any of those optimization algorithms. What is the main difference between PIP version of Theano and the bleeding edge one? So there isn't really a single main difference. The bleeding edge version contains a number of developmental features. So I mentioned earlier, for example, OpenCL being one. So it's best to keep track of those changes through the Theano GitHub project. But yeah, there's not a single main difference which says if you are in this category, you should use the bleeding edge version versus the standard version, the main branch. I believe there was a question last week as well about does Theano support 3D spatial volumetric convolutions? Yes, it does. There's a function that has pretty much the same structure as the conv2D function that's a conv3D function and allows you to use 3D convolutions. Okay. Is there a demo or trial site where we can test Theano, I would recommend you go to the hands-on lab, and should be back up in a couple of hours, and there you can certainly hands-on test Theano there. Okay. If I use QDNn or Theano under Linux, is it good to put the monitor onto a card other than the GPU? No, you can certainly train on the same card as you're using for video display. Okay. So does Theano provide any tools to visualize what inner layers are learning? So there's a number of ways you can do this. The short answer to that question is, though, no, Theano doesn't provide those visualization tools. But the way in which you do it, the question I answered earlier about how do you get the updates out of the network, well, that's one prime example is using the get value method of a Theano variable to extract the weight matrix. That weight matrix then contains those convolutional filter values, for example, in a convolutional neural network, and then you can just treat those as the pixel values for an image and plot using one of the Python imaging libraries. So, for example, the Python imaging library or matplotlib. Alison actually gave a little bit of an answer to this question in the chat, where she said that she used sklearn Theano, which is another one of the libraries built on top of Theano, and that actually does provide functionality to do that visualization. Going through some of the unanswered questions from last week. Does Theano support other languages? Well, the Theano is a Python library, so it's primarily accessed through Python. The backend is compiled into C and CUDA. It is possible to modify the C and CUDA code. For example, if you want to add new operators into Theano, somewhat complex to do that as you're having to use the interface between Python and C, the API between Python and C. And again, because Theano is part of the Python ecosystem, if you're using some other environment that calls other Python functions, other Python methods, then you certainly can use Theano scripts in those Python applications that are being called. Is it possible to take a trained Theano model and port it to an embedded system? Absolutely, it is possible. It's a little bit, so for taking as example the Jetson TK1, the embedded development system that NVIDIA produces, that runs a version of Linux, and so you can actually do a pip install Theano in the same way as we described last week, and then any Theano script you've written on your development system, you could transfer over to your Jetson. I guess to compare and contrast that to how things worked in Caffe, it's slightly different in that in Caffe you had a Caffe installation on your development system, you had a Caffe installation on your embedded system, and then what you were doing was taking the model that came out of the development system and then porting that to the embedded system. And Caffe took care of how a model was structured, how it was saved to disk, and you just had to copy the file across. In Theano, there was really not the same standardized way of saving out a model once you've trained it on your development system. So you would need, in fact, to have some scheme for doing so, for saving out all the parameters of the model, so that you could transfer those across to Theano on your embedded system and then re-import that model into memory. And so you would need the associated scripts to load that model however you've defined it back into memory. And Julia's just put a link to loading and saving, a tutorial on loading and saving in Theano, where I believe they use Pickle and possibly among other things. Okay. Is it a good idea to load a data set into a Theano shared variable? How do you deal with computers with low GPU memory? So that's exactly what shared variables are for in Theano. Therefore, they're hybrid variables that can be used in symbolic expressions, but you want to define a data value for them at the start of your application. So definitely loading a data set in. Where you may have a challenge is as you mentioned, if the size of the data set is larger than GPU memory, you wouldn't want to attempt to load the whole data set into a Theano shared variable initially. So this is where you would actually use, for example, in convolutional neural network training, you would use mini batches of images that are smaller than your GPU memory, and you would update the value of the shared variable each time you wanted to update the mini batch that was currently being operated on. But yeah, that's exactly how you would use shared variables. Okay. During learning, it's very important to monitor the training process. Training and validation errors graphically. Is this easy to do? So I touched on this earlier. This is very easy to do, and you will see it almost being done in most of the Theano tutorials. The way you do it is that your training and your validation error would be outputs of your Theano function, so that each time the function is called, each iteration through the data set, you get an output of those errors. And then you could, again, plot those using any Python plotting package you wanted. So matplotlib, for example. Often people actually define multiple Theano functions. For example, one that's for producing the error for the training set, and one that's producing the error for the validation set. And the reason you do that is because then each time you iterate over your data set, you don't necessarily go through the cost of producing the validation error as well. You may only want to validate your model every 10 iterations. So each time through the data set, you call your train function and get a training error cost. But then every 10th time through, you call your validation function. And those functions can certainly make use of many of the same symbolic expressions in common. You don't have to redefine all the symbolic expressions. You're just simply compiling two different functions. Okay. So how is a Theano function different from calling the same Python function defined separately multiple times? So I referred to Theano functions many times this Q&A and last week. The difference is that if you define a Theano function, that gets compiled to your computational architecture for, well, there's two differences. One, the Theano function can be defined in terms of your symbolic variables and expressions. A general Python function can't be. And two, you when you define that function, you compile those expressions down to efficient code on your computational architecture, whether it be CPU or GPU. So if you just defined a Python function and called that multiple times, you wouldn't be able to take advantage of the underlying parallel computational architecture. Okay. So if you have a classification problem where a possible classification is none of the above, is it better to try and treat none of the above as a class in its own right and try to provide realistic samples of none of the above class? Are there better ways of handling prediction weights to infer than either? So yeah, that's always a difficult question. It is best if you can get a training data set that represents data samples that you are likely to encounter at test time that don't represent one of the classes that you're training on and are interested in. It's very hard to define a classification problem that is going to be able to reliably interpret any previously unseen type of input and just say, well, it's not one of the things I've already seen. A straightforward question about the hands-on lab. For the two classes, how are the plotting colors decided? It's completely arbitrary. I believe the red and the blue are the default that matplotlib uses if you don't tell it any different. Okay. How do you figure out the last extracted convolution features of the network? So Alison, I believe, has already posted a link to a great tutorial on doing this that's presented as an IPython notebook like we do in the labs. It's very good for going through how to do that. In short, I've mentioned the pieces already today. What they do is they use that get value method for the symbolic and shared variables, and then they use, I believe in that example, matplotlib for plotting those convolutional features as images. I wonder whether in that question what was actually meant as well was how do you often what people do is use a trained convolutional neural network as a feature extractor by taking the output of the penultimate layer of the network rather than just the final classification. It's the same method there. If you wanted to pass data into a trained network in Theano and extract one of the feature layers, you would again use that get value method. Okay. Okay. Are there any libraries that implement exploding gradients in Theano? I'm not sure. I assume the question there is libraries that help you deal with exploding gradients. Exploding gradients are a problem in training neural networks, not something you would want to implement. They are the exploding gradient problem is kind of, it does what it says. There are cases where your gradients can become so large that and unrecoverable, and basically that means your optimization problem diverges and you don't converge onto some optimal set of parameters. So the exploding and and vanishing gradient problems are both problems that are commonly encountered in recurrent neural network training. Certainly, Theano supports the definition and training of recurrent neural networks, but the mitigation is not really a language or framework-specific function. The mitigation is more about how you actually define your network and your training algorithm. And so in the case of recurrent neural networks, one method that was proposed for addressing that is the long short-term memory network, and certainly you can implement that in Theano, and I believe the Theano deep learning tutorials have an example of doing that. Someone asked, when they were training a deep learning network, the power was cut off for some reason. Can they use the save and load method to reload their previously terminated network? Unfortunately, well, without further information, I would say you probably can't, unfortunately. The use of the save method is certainly not automatic. That's something that you need to choose when to use within a Theano application, when you want to save those parameters out. So if you weren't doing that, you wouldn't be able to load them. There's no automatic saving. If you were doing that, then yes, you should be able to load your previous network back into memory. Okay. There was a question, actually, I think came up last week about performance. Caffe versus Theano for similar deep learning problems. There is a lot of moving parts in answering the question. It's never straightforward. One is faster than the other across the board. It depends on the network type and data, etc. There's a link to some ConvNet benchmarks that give you some indicative comparisons, some comparisons for specific problems. I'll paste that into the chat. One comment I would have is if you are using any of the interfaces to Caffe, you have very low latency in loading a network configuration into memory and passing data into it. Theano does have a compilation step. When you run your application, you define your symbolic expressions, then you define a Theano function that has to be compiled. That does introduce an overhead at the beginning of the application. Now, whether that matters for your actual application is application specific. If you're going to be training for 2 weeks in either system, the 5 minutes to or not even 5 minutes, the 30 seconds to compile the Theano function is probably not important. But if you're passing in a single data sample for classification and you're going to do that many times, you may find that compilation step a challenge, but there are also ways to mitigate that overhead by keeping the function compiled and passing in new data samples as they arrive with the function still running and compiled. Okay. Is there a way to bias network training towards false positives, say one wanted to be very careful not to identify a 9 unless it was very likely a 9? Yep, there's certainly ways to do that. You can, in Theano, you have complete control over your loss function. I mean, you have to define your your loss function, so it can certainly be a weighted loss across each of the classes, so that penalizes errors in certain classes. In Café, you don't necessarily have that. Well, you can define new loss functions, but just using the standard Café functionality, you can actually define multiple loss functions and have those weighted. So you might choose to formulate your problem in Café as multiple binary classification problems, one for each digit, for example, and weight them differently. There are a number of ways to do that, but you can certainly bias network training by modifying the loss function. In digits, there's a digits question that came in. I notice a parameter named snapshot intervals. Is this parameter to set up the backup period? Yep, that's exactly what that does. You're specifying how many, after how many iterations, so how many times through the data digits should save out a Café model and the associated prototext files. So the question that came in before about power being cut off is pertinent, because if you fear that that might happen, then setting a frequent snapshot interval will mean that you minimize your losses when that did happen. Okay, I'm just going to answer a couple more questions. Is it possible to define non-square convolutional filters either in Theano or Café? Yes, it is in both. The convolutional functions in both give you freedom over the two dimensions of a convolutional filter independently, and I believe the 3D convolution implementation similarly. You have control over the 3 dimensions independently. Okay, and I'm going to answer one more question. Great question. What is the advantage with respect to Torch 7? Well, I would recommend that you come next week for the Introduction to Torch 7 webinar to hear about Torch 7. They're actually more similar than they are different, really. But the main differentiator is the symbolic maths representation in Theano. So if you are mathematically oriented, or you want to understand how the mathematical representation of neural network training translates to computational implementation, then Theano may expose more of that detail to you, but Torch 7 has a very concise, powerful syntax for defining and training neural networks. In some ways, it's probably fair to say Torch 7, just from a syntax perspective, is more similar to Keras or Lasagna than it is to Theano itself. But again, the choice between the two would be application specific and your programming language of choice specific. And I highly recommend you come back next week and hear my colleague Alison Lowndes do a Getting Started with the Torch Framework webinar, for which there'll be an associated lab. And at that point, I'm going to finish. Thank you very much for attending, and hopefully the hands-on lab, as we mentioned, will be back up within the next couple of hours.
Yeah, it's actually up and running now, John, so we're good to go.
Great. Thanks, Mark.
All right, bye, everybody.